Let's talk about unit conversion. Um, Quantities that we measure or that we calculate have to have a unit for them to be meaningful. With the exception of some ratios and some other types of quantities, but most measurable quantities have units. And you measure it, you get units off of the measuring device that you use. But let's say you measure, like in example one here, let's say you measure a length in inches because your tape measure says inches and that's all it says, but we like it to be in SI units. So what are SI units? Well, SI units are the international system. It's just the set of units that the global scientific communities have generally agreed to use. There are some properties of SI units that make it useful, and we'll talk about those in a little bit. But by and large, we just have to agree on something so that it makes conversations among scientific communities less cumbersome. But some countries don't use SI units as their official system. The United States is one of them. So let's say we have 10 inches, and we'd like to convert it to the SI unit. The official SI unit for length, because an inch is a length, is the meter, right? Abbreviated with a lowercase m. So we're going to go from inches to meters. What I need to do this is a conversion factor. And a conversion factor is just an equality. It wouldn't be great if I had a list of those somewhere on a page. Oh, hey, right here. Here are some conversion factors. This is by no means a complete list, but it is a short list. We have some for length, for time, for mass. There are other things that you can measure, but length, time, and mass are fairly fundamental, and lots of other quantities are actually combinations of these. If you talk about a speed, it's a length per unit time, right? You can talk about a density, that's a mass per unit volume, and a volume is a cubed length. So those two things come from these three basic units. So I have a couple conversion factors here. I have an inch to centimeters. Let's highlight that. Ooh, I think I even have a highlighter. Right? There's an inch to centimeters. That might be useful. And then how am I going to get from centimeters to meters? That's where I'd like to go. Well, I don't have an equality here for centimeters to meters, but centi is a prefactor here. It's a metric prefix, right? Centi is a metric prefix. It's the letter C. It is a hundredth, right? So what we should think is centi means 10 to the minus 2. Centi means 10 to the minus 2. So anytime I see the words, the prefix centi on a unit, I could just replace that centi with a 10 to the minus 2, and I'm good to go. I also like to build unit conversion or conversion factors out of these, right? So what do we have? Centimeters, and I'd like to relate that to meters. Well, what do I know about centimeters? Well, I could do this. I could say, well, 1 centimeter must be 10 to the minus 2 meters, right? Because centi here can be replaced with 10 to the minus 2. But the other thing I could do, because this is an awkward conversion factor, but I know there are 100 centimeters in a meter, right? Centi, as in like century, that means 100. So I could also write 100 centimeters is 1 meter. Those two equalities are both true, and either one of these will work for me. I tend to use this one because it seems a little less awkward. Okay, so I think we have our conversion factors. There's one conversion factor, and the other one is the 1 inch is 2.54 centimeters, which is exact, by the way. That's not an approximation. That's exactly what that conversion is. Okay, so let's do this then. So we're converting 10 inches, and I'm going to multiply by these conversion factors. and I'm going to multiply by a fraction that is equal to 1. How do I make a fraction equal to 1? Well, the numerator and denominator are equal, right? So let's grab those. What were they? 1 inch is 2.54 centimeters, and 100 centimeters is 1 meter. Be careful. I don't know if you're anything like me. It's easy to write this wrong and to say 1 centimeter is 100 meters, but you should read the conversion factor and make sure that it kind of makes sense. If I had 1 centimeter equals 100 meters, I would think 100 meters is long and 1 centimeter is short. So this is the right way for this to be. Okay. So let's go inches to centimeters first. Again, I'm just going to want to multiply by 1. So I'm going to put the inches downstairs and the centimeters upstairs. There we go. And you see inches and inches cancel, and I'm left with this centimeters. Okay, that's great. But centimeters isn't my end goal. Centimeters is a way station toward my end. So I could do the math. I could multiply, because what do I have? 10 times 2.54 divided by 1. I could do that math and then do the next conversion, but let's do it all in one step. That seems a little simpler. So 10 inches now converted to centimeters, and now I want to go from centimeters to meters. So meters is where I want to end up, and centimeters needs to go away, right? And for this equality to be equal, it's 100 centimeters per meter. Okay, so now I can see centimeters, and centimeters goes away, and I'm left with meters, which was my goal, right? That's where I was going. So then I can do this math. So it's 10 times 2.54 divided by 100. Looks like it's going to be 0.254 meters. Right, so that's a quarter of a meter. 10 inches is probably about a quarter of a meter, because a meter, if you think a meter and a yard are about the same, 10 inches is a little less than a third of a yard. So yeah, this tracks. Plus our math is right, so that's right. The one last step with this, you could think, well, 10 inches started with, 2 digits here. Do I really need to keep this 4? And the answer is a little ambiguous. It kind of depends on how many significant figures that 10 inches had. But sig figs is a lecture or topic for another video. For now, I'm going to cut this off. I'm going to cut that 4 off. So what could I do? Oh, look at that. That worked. Great. And since I have a final answer and a lot of work here, let's circle it. All right, let's do another one. So 52 feet per second. So that's a rate, right? Anytime we have something per unit time, that's some kind of rate. I'd like to convert this to SI units. So what's the SI unit for a distance per time? Well, I just need the SI unit for distance and the SI unit for time. The SI unit for distance is meters. The SI unit for time is seconds. So I don't need to touch the seconds. I just need to go from feet to meters. Now you might be able to use intuition here, right? Because we just said a meter and a yard are about the same, and I've got a bunch of conversion factors in my head from my childhood because I grew up in the United States. So I know there are 3 feet in a yard, so there's about 3 feet in a meter, but I don't know exactly what it is. And I don't think the other conversion sheet said. We could look it up, right? You can use your favorite search engine and find exactly how many feet are in a meter. Or we could say, well, I know there are still 2.54 centimeters in an inch. And I also know off the top of my head that there are 12 inches in a foot. Right? I also have the number 5,280 in my head. That's feet to miles. And I think 1,700 and something yards in a mile. Again, having those in your head are not super important. And I'll talk about that in maybe just a second. Okay. So, this conversion factor will get me from feet to inches, and then I can go inches to centimeters, and then I can go centimeters to meters. That seems like a lot of steps, but I didn't have to pull too much out of my head, right? Because I already had 2 of those conversion factors. I just needed 1 more. Okay, so let's do this. 52 feet per second. Now I'm going to write it as a fraction vertically, right, up and down, rather than in line. It typesets better in line, but for our fraction math, it actually works better this way. Okay, so I don't need to do anything with the seconds, so I'm not even going to touch it. So my first conversion is going to be feet to inches, and I need the feet to go away and the inches to show up. So that's how I'm going to put this conversion factor. And what is my conversion? It's 12 inches per foot. So the 12 goes upstairs and the 1 goes downstairs. Okay, great. And now I want inches to go away and centimeters can show up. That's great. So what do we say? 1 inch is 2.54 centimeters. Fantastic. So now inches goes away and centimeters shows up. And now I want centimeters to go away and meters to show up. So there's 100 centimeters in a meter. And now I can go back through feet, and feet go away, inches and inches go away, centimeters and centimeters go away, and I'm left with meters and the second that was initially there. Fantastic. Okay, so all I need to do now is plug all of this into my calculator, right? So it's 52 times 12 times 2.54 divided by 100. All of these ones are super convenient. It doesn't always work out that way, but they are convenient in this case. What I get is 15.85 meters per second. And again, if I'm thinking sig figs, this is all multiplication, so I'm just going to keep the number of sig figs that the original thing had. Again, I'll talk more in depth about that in another video. So there's 2 sig figs here, so I'm going to round out those 2. So I'm going to round this to, oops, I would rather that be a pen, 16 meters per second. And I would really only round this if this is the last step. If this is my final answer, I would leave this. If this is a way station toward another answer, I would leave all of those numbers in my calculator. Fantastic. Let's do another one. 72 miles per hour. MPH is miles per hour, right? I want to go to the SI unit. This is still a rate, so I'm still going to meters per second. Right? It's a rate of change. Again, you can have a rate of change of lots of things. But this is a rate of change of distance, or a displacement per unit time. So it's the same sort of quantity. So now I need to change the numerator and the denominator, right? I need to go from miles to meters and from hours to seconds. So let's see. We had a conversion on the other page. Let's go back. We had a conversion factor that was miles to kilometers. That might help us, right? In fact, let's use our highlighter again. Maybe we'll use green this time. So here's miles to kilometers. That's going to help us. And then I can go from kilometers to meters. And kilo, in my list of metric prefixes, kilo is 1,000, which is 10 to the 3. Okay. So I could write out the conversion factor here, right? Let's do 1 kilometer equals how many meters? Well, the kilo, that K, I'm just going to replace that with this 10 to the 3. So that's 10 to the 3 meters. But 10 to the 3 is 1,000, right? So 1 kilometer is 1,000 meters. Maybe I will use this version because the other thing I could do is say 1 meter equals 10 to the minus 3 kilometers. But this isn't super awkward. Again, I could just write this as 1,000 meters if I wanted. Okay. That's useful. I also have hours. Maybe we'll go back and we'll deal with the time in a second. It's kind of funny, right? Okay. So let's do this. 72 miles per hour. Yeah. 72. Give myself a little more space. Miles per hour. And I wrote out miles, or sometimes I'll use MI, because if I abbreviate miles with an M and meters with an M, That's confusing, and I do my best not to do confusing things. Okay, so so I can make the miles go away. We had a conversion factor that was how many miles there are in a kilometer, or really it was the other way. It was 1 mile and 1.609 kilometers. If you're confused about which one is bigger, you can remember if you've ever run a 5K, it's 3.1 miles, right? That you could use that as your conversion factor. It's only good to 2 sig figs, but a 5K is 3.1 miles. So the kilometers are smaller than miles, which means this must be the conversion. Just a way to remember that. Okay, so that makes miles go away, and now I want kilometers to turn into meters. Oops, darn. That's funny. My apologies. I am new to the Apple Pen. Okay. So kilometers goes downstairs, meters goes upstairs, and there's 1,000 meters in 1 kilometer. This is one conversion factor that is really easy for me to screw up. This is in the way, so I'm just going to erase it. Why not? Okay. This is a conversion factor that is really easy for me to screw up, right? So I always double check my thinking on it. Okay, so kilometers goes away, miles goes away, meters is what I wanted. So now I want hours to turn into seconds. So I could put my hour up here and my second down here. Do you know off the top of your head how many hours are in a second? Well, it'd be a small number of hours in a second. So how many seconds are in an hour? Well, if you don't know this off the top of your head, you can step through minutes, right? How many seconds are in a minute? There are 60. How many minutes are in an hour? There are 60. So that's 60 that shows up twice downstairs. That's actually 3,600. Come on. 3,600 shows up right here. Okay. Let's double check that all our units work out. Miles and miles, kilometers and kilometers, it leaves meters. And that hour goes away, they're seconds. Okay. So if you do this math, right, 72 times 1.609 times 1,000 divided by 3,600, you get 32 meters per second. Notice that's close-ish to a factor of 2, right? Half of 72 is a little bigger than 32. So that's a good rule of thumb if you're thinking 60 miles an hour turns out to be like 26 meters per second. So if you're going from miles per hour, that gives you a good sense of, when I get an answer in meters per second, how fast is that really? I know personally, I have a better sense of how fast something is going in miles per hour, like what that feels like versus meters per second. Okay, let's do one more. Inches squared. Okay, so that's an area, right? And I want to convert this to meters squared, right? I just replace the length with the SI unit for length, and I'm going to have to do it twice. So we'll see what that looks like here in a second. Okay, so 2.5 inches squared times, well, I know that the inches to centimeters conversion, right? So let's throw that in there. Inches to centimeters, that's 1 inch and 2.54 centimeters. But that's only going to change one of these inches. I need to do this twice. So I could write this again, or I could just square it. Do you see that? So now square inches and inches squared are going to cancel, and I'm left with centimeters squared. We're close. We're close. So now I need to go from centimeters to meters. Right? So centimeters downstairs and meters upstairs. And there are 100 centimeters in a meter. But I need to square this factor as well because there are two of them, right? So inches squared and inches squared, and then centimeters squared and centimeters squared, right? Which leaves me meters squared as my answer. I hope you're able to follow that. Okay. So 2.54. So the trick here is I need to square the 2.54. So 2.5 times 2.54 squared divided by 100 squared. That gives me 0.001613. Oops, that doesn't look very nice. I'll write it below it a little bit. 0.001613 square meters. Square meters, please. Or I could write that in the scientific notation, 1.6, and let's just drop the rest of the digits, times 10 to the minus 1, 2, 3 meters squared. Okay, that's only slightly illegible, which I'll take. Okay, let's call that good. And yeah, thanks for watching.